All right, how's it going today? So I finished grading everybody's SLP, and if you did not get a grade, you've got comments on there, unless I just missed it somehow. You should have comments in the submission block asking you to expand on something or clarify something or add something, so please do that as soon as possible. If you have not turned in your SLP proposal yet, it's too late for version 1, but go ahead and turn in under version 2. Also, it looks like almost nobody has signed up to present their SLP to the engineering club. It's extra credit. It's a chance to work out some of your ideas, present it to a friendly group of fellow students in the audience, and get some useful feedback. And it's a good thing, right? Even if it's not extra credit, which it is.
So we don't need a prototype or anything. We just have to come up with an idea.
It's just basically presenting what's in your proposal, like just talking, but you don't have to read the proposal. It's just talking to the club and telling them what it is you plan to do, what the scope of it is, things like that, and then just sort of answering questions. So the most useful way sometimes to understand something is to try to explain it to someone, right? If you can explain it to your cat or your dog, that's like the best of all, because you got to go down to really simple starting points. I should know that, but I don't. Is it 10 points? Let's see. $10 points sounds right, but it should be somewhere. So up to 10 points on there, and the whole SLP, I think I made it come out to 100. So it's 25 for the proposal, 25 for the presentation, 50 for the upload. So it's an extra 10% on top of your SLP grade, and the SLP is, I think, 15% of the final grade. So that's like 1.5 points added to your final course grade. So that's fairly significant. But don't plan on signing up, week 8, because there's only like 5 or 6 slots each week, and if 100 students decide week 8 I should get some extra credit, right? It's going to be whoever the first 5 are to sign up, and that's that. All right, I want to talk about fgets today. Go through some details of that because we're using that in PA2. I want to talk about some aspects of that. But any questions before we start? Haven't heard a lot of questions on PA2. I'm hoping PA2 is basically done for most people, and that's why I haven't heard questions on it. But that may not be the case.
There's nothing specific we have to return when we exit the program.
Nope.
Okay.
Yeah, you can just return if you make it void, or just return a number of your choice. All right, well, let's play around with fgets. So fgets is reading standard in, right? It's reading input the user types, it's storing it in an array, and it's returning some value to us. So let's make a temporary character array called temp. Let's make an integer called status. Let's prompt the user to enter something. and I'm going to say read the user's input into this array temp. We can read up to 120, we can store up to 120 characters in temp, and we're reading from standard in. Standard in is always the third argument if you just want to read from standard in. And we'll go ahead and we'll just print out the value of temp. So say something hello, and temp is equal to hello with the new line at the end. Right. And it pretty faithfully reads whatever you type in. It's not like Bash that sort of eats multiple spaces and uses them as a separator. Pretty much whatever you type in, it's going to get loaded into temp. Including if you do things with like weird characters in it, right, which will move the cursor around in backspace and strange things like that. And if I just hit enter, then temp is a single character, which is just a new line. Okay, so there's always a new line at the end of our input. So I'm going to print out the length of temp using string length. I'm going to include string.h so I have access to string length. It'll complain, but I don't care about that. So if I say hello, it tells me the length of temp is 6. All right, HELLO, 5 letters plus a new line. If I just hit enter, the length of temp is 1. It's just a new line. All right, fgets actually returns a value also. So if you do a man on fgets and come down to return value, it tells you fgets returns s on success, null on error, or when end of file occurs, while no characters have been read. So what is s? S is this first argument to fgets. It's the array that we're trying to store characters into. And it returns the address of that array normally. Why? Because it does. But the important part is if it does not succeed in reading any input, it'll return null. Okay? Null is a special value. It's an address that's never a valid address. So null will never be the address of our array S or temp in our program. So we can use this to do something like this. We can say, let's call fgets, let's read 120 characters, save it in temp, and then let's take the return value from that and see if it's equal to null. And if that is equal to null, we know that fgets encountered what we call end of file. There was no input available to read. So I'll just say no input available, goodbye. And I'll just return. Otherwise, I'll go ahead and print out temp, print out the length of temp. Alright, so this is something we're going to do in a while loop next. But this is basically checking the return value from fgets. So if I run this and I say hello, that's fine. If I run this and I just hit enter, that's fine. It didn't hit end of file. It had a single character input, which was a new line. Okay, here's how we change the behavior. If I hit Control D, and it's the first character that I'm typing, that will signal to the system end of file. It acts as if there's no more input available, and fgets will return null. So if I want to indicate that I don't have anything to say, I hold down Control and press D, and it detects null and it says no input available, goodbye. So it's not that Control D is equal to EOF. Okay, Control D is just a trick that is used by fgets for us to indicate that we're at the end of our input, that there's no more input available. And if I say hello Control D, it just reads hello. Okay, but if Control D is the first thing on the line, it will interpret that as saying there is no more input coming, and fgets will return null to indicate that. Does that make sense? So we can use this to do something like a while loop. So we can do this as long as there is input available. So as long as there's input available, we'll print out temp, and we don't have to keep printing its length. We'll just print out the value of temp, and we'll prompt the user again. And then when we finally hit Control D, fgets will return null. We'll kick out of the while loop. We'll say no input available, goodbye. So I can say hello, and it says temp equals hello. This is fun. That had typos, etc. Alright, so then when I hit Control D, it detects that end of file occurred. It says no input available, goodbye. And if I want to clean that up, I should probably put a new line in here, because I'm not printing a new line after say something. Ooh. Alright, does that seem reasonable so far? Mm-hmm.
So what other value that fgets can, the result of fgets can be?
So it's either going to be null or it's going to be the address of temp in this case. Right, so we could do this. So I got three things going on in the statement now. I'm calling fgets. I'm saving the return value from that into this temporary variable called result. And then I'm checking to see if that's different from null. And then if it is, I'm going into the body of the while loop. So I'm actually doing four things in that statement. But let's just go ahead and print out the value of result. And I know it's a pointer to a character, so I'm printing out with a %p. And then let's also print it out once we get end of file. I've never done this in my life, so we'll see what happens. Alright, say something hello. So the result from scanf was a weird hex number with 12 hex characters, and then temp equals hello. And every time I do this, the return value from fgets is going to be the same. It's just the address of our array temp. Until I hit Control D, and then it says the result is nil. Well, that's null. It's a 0. And if I run it again, the address of temp is different. Right? These things don't always go in the same location. And I can totally double check this. I can actually print out the address of temp. Well, temp is an address. So I can just print out the address of temp also with a %p, and it should be exactly the same thing as what fgets returned. Right, so they're both 7FFF, 2B10. But mostly we just check to see if it's null. So that's the standard input loop, right? And most things in Unix, Control D means end of input, right? End of file. Yeah, go ahead.
So are we, every time we do this while loop, are we storing things after one another in temp, or are we overriding temp each time?
We're overwriting temp each time. So fgets starts with the first character in temp. That's where it writes the first character that you input.
Okay.
So it gets completely rewritten. All right, so what happens if we have more than 120 things, or if we set ftemp to hold 5 things and we tell fgets to read 5 things? What if we type more than 5 things? And let me get rid of the result stuff just to simplify this. Okay, so if I just say hi, it reads in hi. If I say okay, it reads in okay. If I type in something more than 5 characters and I hit return, it goes through our loop 3 times. And I said temp's ABCD, temp is EFGH, temp is IJKL, and then temp is a new line. So here's what's going on. We have this thing called standard in. For now, this is our keyboard. You type, and that's feeding standard in. Standard in is kind of going into sort of this pipeline that we can call an input buffer. And fgets is reading from this input buffer. So if I type hi, enter, there's an H, an I, and a new line sitting in this input buffer. And my code says, let's go ahead and read up to 5 things from standard in. Well, it's really reading not directly from the keyboard, it's reading from this input buffer. And finds an H, an I, a \n. When it gets to \n, it's done. That's 3 things. That'll fit in temp, so it loads that into temp, and we're good to go. Now, if I type a bunch of things like A, B, C, D, E, F, G, and a new line, and then I get to fgets, right? Once I hit the new line, fgets starts looking at the input buffer. It can load up to 5 things in temp, so it's going to read A, B, C, D. It's going to put those in temp, and it's going to put a null terminator at the end. That's 5 characters. That's going to fill up temp. So it loads that into temp. The code runs. It prints out temp equals. It prints out say something. It goes back and it calls fgets again. And what does fgets do? It comes in and it looks at the input buffer and it sees an E, F, G, and a new line. And it's going to read those and it's going to put them into temp. It'll be 4 characters long plus a null terminator, and it'll print that out. So it's not necessarily waiting for you to type something every time you call fgets. If you type in more stuff, then it can ingest the stuff you type. The extra stuff is still sort of sitting in a buffer. And the next time you call fgets, if it finds either enough to fill up temp or it finds something ending with a new line, it'll grab it right away and process it. Yeah?
So how do you clear that out?
You usually don't. I mean, you can keep calling fgets or getcar and it'll keep reading it up. But if you call fgets and there's nothing in here, then fgets is sitting there waiting for you to type something. So normally we don't run into this. This is why on most of my assignments there's things like you can assume the input is no more than 1,000 characters, which says make your buffer 1,000, and this will never happen. But I mean this happens all the time. right? So I just typed 3 things into bash, but I've got a sleep command running. So that stuff is in the input buffer. Once the sleep command finishes, it'll read up to a new line, which is pwd, print the directory, and then it'll go back and it'll read from the input buffer up to a new line and see date, and it'll execute the date command and so on. And of course, if you do something like this, where you tell fgets to read up to 120 characters, but you don't have enough space for 120 characters, then you get stack smashing. And that's because I told it could read all of that into temp, but temp was only big enough to hold 5 things. So when it tried to put the 6th thing in, it detected that something bad was going on. Alright, still with me? Alright, so let's clean up something that some people have asked about. I say hello and it says temp equals hello with a new line at the end. That new line can be a pain. Sometimes we want to get rid of that. So I said hello, but temp's actually equal to that, right? Plus a null terminator. So let's look at temp as an array. So this is HELLO, new line, and then a null terminator. So suppose I wanted to change temp to just be HELLO with a null terminator. In other words, I want to get rid of that new line so that every time I print it, it doesn't automatically throw a new line at the end. Because maybe I want to print it out and say something after that. So what could I do, at least in this particular case, if that's exactly the value of the array temp, what could I do to get rid of that new line? Yeah.
Tell it not to print what's in the address of the line.
Okay, how can we do that? That's exactly right. Yeah.
Cart into and then set it to run, and then just put a null terminator.
Okay, so if we could change this to be a null terminator, our string would suddenly be only 5 characters long. It would be HELLO and there would be a null terminator, and printf just starts printing until it finds a null terminator and then it stops. So the trick here would be to say something like temp bracket 5 equals quote \0. So initial value of temp, we'll print that out and then we'll modify it. And then we'll print out the modified value of temp. So if I say hello, the initial value has a new line at the end. The modified value is nice HELLO. And the bracket comes right after that. But if we do haha, it doesn't seem to work. Or worse, if we do something like this, if we do this as fun, it changes it to just this space. And these are exactly what we asked to do. We asked it to take the 5th element in the array, right, sixth element, bracket 5, and set that to a null terminator. This is truncating the string after 5 characters. So if the string is shorter than 5 characters, it has no effect. If it's longer than 5 characters, it has the effect of chopping it off. So suppose temp was equal to haha \n . So what character do we want to change to the null terminator in this case? Character 4. So is there a pattern here?
It's the end of the string length minus 1.
It's the string length minus 1. Right? So if temp is equal to hello, the string length is equal to 6, HELLO, and the new line. If it's haha \n, string length is going to be equal to 5, HAHA, and the new line. So if we allow ourselves to generalize, it looks like temp string length temp minus 1 is the character we want to change to the null terminator. And it takes a little brain wringing to convince yourself that this is true in general, but you know, most things, if they work 2 times, they work forever. Certainly if they work 3 times, they work forever, except for, you know, those unfortunate exceptions. But you know, there's a pattern here. So the string length is the number of characters, and the index of the first character is 0, second character is 1, third character is 2, nth character is n minus 1. Well, string length, right, that's the number of characters. So the last character, which is the new line, is the one right before that. So string length temp minus 1. So let's try that. So temp bracket string length temp minus 1. So replace that with the null terminator. Right, so that's a recurring trick to get rid of that new line, is to use array name bracket string length array name minus 1. Set that equal to null.
If we delete the null terminator at the end, can that cause problems?
If you delete the null terminator, that will definitely cause problems. But let's do that just for kicks. So what's the index of the null terminator? It's the string length. If string length is 5, the null terminator is actually sitting at index 5. Right? So let's just change it to something that's not the null terminator, like the letter X. And then let's go ahead and print it out. So it looks like my string is hello, new line X. If I say ha, my temp is ha space X lowercase o, new line X. What the heck is happening? Okay. All right, and what's happening here, we're not terminating the string at the end of the input, and so printf thinks the string goes beyond the OKAY new line, and what does it find there? It finds stuff that was sitting in our character array before we called fgets.
You change the new line to
I took that out. I commented that out. But even if I hadn't commented that out, well, this is going to work. This is not going to work. Because as soon as I remove that null terminator, string length doesn't work anymore. Because what does string length do? It starts at the beginning of your array, it looks for the null terminator. And so if I remove that null terminator, then it doesn't know where to find the new line. Alright, so that's a good thing to do. Thing before is not. Yeah?
So why use fgets versus scan?
scanf doesn't actually do input, right? So fgets says read from standard in, or more specifically read from the input buffer and save it into a string. scanf, the only thing that does is says here's a string of characters, let's interpret it. Let's create an integer based on what we find in this string, right? So fgets is an input operation, and scanf is more like what we would call parsing. It's interpreting that string and changing it into other things. And those two almost always go together. Gets we don't want to use because it's not safe from buffer overrun. And scanf also has that problem. So it's really these two together that we want to use whenever we're doing input. And other than the null terminator, which is either a feature or a bug, depending on what you're trying to do, other than the null terminator, right, fgets is pretty much doing exactly what we want it to do. And if you don't want the null terminator, you can just throw in one line to remove it.
So if we maybe did our PA2 without using fgets,
How did you do input? Like when you ask the user how many sticks they want?
probably scan it.
Okay, so scanf, right, we've got this problem. If they type in something that's not an integer, you're going to get stuck in an infinite loop, most likely.
I don't know what I did about it. I don't remember I did this last week.
You can shoot me a copy of your code if you want, and we can look at it. By the way, if you want to send me code, like, ODPs or something like that, try not to do a screenshot, try not to do Canvas email, okay? Take your whatever tool you're using and just grab your code and then paste that into just a plain email message to nmacias@clark.edu. If you send me a screenshot, if you send me through Canvas, I can't look at it until I get to a computer, which is often not right away. If you just send me an email message that contains this as the message itself, it's really easy for me to look at it, and it's really easy for me to copy it and paste it in and try running the code myself. And I won't always do that. Sometimes I'll say, looks like you got a bug, good luck. No, I won't say that, but But it helps me to be able to see what you're doing to try to offer advice. Alright, so that set of code is on the server that you can get to from Canvas. Alright, other questions about that? let's talk a little more about Linux stuff. So we'll just play in here. So if you want to look at a file, right, you can VI it, obviously. That's what we usually do. But VI, to me, is a little scary, right? It opens up the file for editing, and if I just kind of accidentally lean on my keyboard, or I'm distractedly doing something, right, my file gets wonky. And if I :X habitually to get out of VI, I'll actually write those changes. So I'll :Q, and it won't let me do that, and maybe I get frustrated and do :X, which is bad, or do :Q exclamation mark, which is better. So VI is really not something I personally like to use if I'm just looking at a file. So the actual command for looking at a file is just cat, and it's actually short for concatenate. But it takes the contents of a file and it displays it on your screen, and it doesn't open it up for changing and so on and so forth. That's not a bad command, but if you're looking at a big file, it just spews it out on your screen and comes back with a prompt. And my file, actually, the output started way up here somewhere, so I gotta scroll and I gotta look, and I'm playing video games now, right? And right there is where my file started. So there's a better command for looking at files, and that command is called more. So if I say more and the name of the file, it shows me my file one screen at a time, right? So the top of the page is the first line of the file. It shows me one page, typically 24 lines, and then it tells me there's more, and I'm 9% of the way through the file. And if I want to see the next page, you just hit the space bar. And it's a nice and big button. You don't have to even look to hit it. And there's the second page, and now I'm 21% of the way through. And so this is a pretty fast way to look through a file. You can also hit an enter and go down one line at a time if you think you're close to something interesting. You can also do basic searching. I can search for bash, and well, it didn't find it, but if I search for bash up here, it'll scroll down to the next spot in my file where bash appears, and it's the third line from the top. And if I hit an N, it would look for that again, but bash only seems to appear on this page. And there's a lot of different commands you can use inside here. One thing you cannot do, though, is Control D. Well, you can, but it doesn't exit. You can Control C, which is a little heavy-handed, but the way to get out of more is Q, just lowercase q, that quits. And that's kind of an exception, because usually Control D gets you out of things. It doesn't work with more.
So we go back a page or story?
I don't know how you do that. There is a way. What I usually do is actually, I'm blanking now how I go back. I know how to go to the beginning. I don't know. Hit a question mark, and there's all the help that's available. So Control B will go backwards a screen full, or just B. Oh yeah, colon. So we can go forward, B goes back. Well, that's pretty easy. It shouldn't have taken me 40 years to learn that. And like I say, question mark gives you all kinds of helpful options. There's also a program called less, and less is a better version of more. I never use it just because my fingers are used to typing more instead of less, but most things that use more in Linux are actually using less now. But I don't know how you get help in that. Yeah, I don't know how to use less, so you can use more or less. Something else I wanted to say. Oh, the other thing is, if you hit a V, it'll pop you into VI, and that can be handy. But you're in a VI session, you're actually editing the file now. So if that was your intent, you're good to go. If you just wanted to hop into VI to move around, just be aware that this is a live editing session. And then when you quit, you're back in more and you can keep going through it as usual. And then the queue quits right away. Alright, another good command is top. Top shows you everything that's going on in the system, and it shows you some synopsis information at the top. So current time, my machine's been up for almost 5 days now, 4 days, 22 hours. There's 2 users. I guess that's both me. Load average. Load average is a measure of how heavily weighted your CPU is right now, how burdened it is. A number below 1, the system's basically idle. 1 or 2, it's doing something, but you're probably not noticing it. 5, you're probably starting to notice some slowdown. 10, there's something pretty heavy going on, but it's just a relative scale. And I think this is current load average, 1 minute average, 5 minute average. So if we jam the CPU, you'll see these go up. And if you stop what you're doing, these numbers will stay high for a while. This one will come down. 280 tasks on my system right now. 280 different processes doing something. Right? One of them is running. Guess what that is? That's the command called top. That's what's sitting right here. Because every time that this program starts, it looks around. It's like nobody's doing anything except me. Right? 234 were sleeping. 0 stop. No zombies. We'll talk about zombies later. And then there's some memory information and so on. And then you get this prioritized list of processes showing you which processes are running and percentage of CPU being taken. So Kazam, which is the screen recorder I'm running to make the videos, that's taking almost half my CPU, very little memory. And then all these things are just background processes. Top happens to be down here for a moment, and it's taking about 1% of the CPU. If you get a problem with Chrome, if it's stuck in some kind of memory sucking state, you'll see Chrome pop up a bunch and it'll be up at the top. My Thunderbird email pops up at the top after a few days. If I don't close it out, it just starts grabbing 100% of the CPU. I've got 4 cores, so my CPU can go above 100. Right, I'll see this as high as 400% sometimes. Total. So, and this command is the other weird one that you can't get out of with Control D. You can Control C it, or you can just hit a Q. And that's useful if you're running your own Linux system and it's kind of dragging and you aren't sure why. Or you can hop on the Linux server and run it up there. And we got some people working on their student projects called Rogue. So this has been up for 33 days. Load average is pretty high right now, but that's mostly Rogue. And these rogues are actually runaways, I believe, because this is saying this has been running for 273 hours, I believe. So I'll peek into these later and probably kill them off because I think they're probably stray jobs, but that's dragging down the CPU. All right, so we'll talk more about processes later, but top's a useful command. Wildcards. So I can say ls, and it shows me a list of all the files in my directory. Okay, if I just want to see the .c files, the source files, I can say ls star.c. And it'll only show me files that have a file name that looks like anything followed by a period followed by a C. Okay, so this asterisk is a wildcard. And there's 2 wildcards we mostly use. Asterisk is the most useful one, I think. It just matches 0 or more characters of any type. So anything followed by a .c. Or if I wanted to see all my files named Go, I could say ls go star, and it shows me all the things that start with GO. You can also use question marks. So question mark matches exactly 1 character. So if I say ls 4 question marks, it'll show me any files that have exactly 4 characters in the name, which is comp and go.c. And so you can put these together in different ways. And it turns out that these wildcards work for most commands. If I wanted to edit all of my .c files, I could say vi star.c, and it'll bring me into the editor for go2.c, and if I say :next, it'll take me to go3, and if I say :next, it'll take me to go, and if I say :next, there's nothing else. So it basically edited 3 files. And I could say move star.c into this directory called sub, and now all my C code is underneath this subdirectory. Should have called it source. So now if I do an ls on source, there's where my .c files are. And if I wanted to copy those in my current directory, I could say copy source/star into my current directory. Now I've got my C files back. But I said copy, not move, so those are also sitting under my source directory. So wildcards are useful. They can also be dangerous, right? So rm star removes every file. But they're useful. And they work with almost every command. And the reason they work with almost every command is because of the shell. So if you look at the code for ls, the C code for ls or for cp or for mv or for vi, you won't find anything in the code which says if the file name has an asterisk, then let's do the following. Okay, the ls command does not know about wildcards. The vi command does not know about wildcards. It's actually the shell that knows about wildcards. So let me do a quick piece of code. See how many typos I can make in like. All right, so there's a little C program that just takes whatever the command line arguments and prints them out. Right, so it's just a for loop. Okay, so check this out. If I run this and I put in a command line argument of star.c, what does my program do? It acts as if I had typed 4 things after the command line, after the command name. So the shell, bash itself, before it starts executing this program, it looks at this star.c and it expands it into a list of file names. So it says in this directory I've got an argcc, go2, go3, and go.c. And it basically replaces star.c with 4 file names separated by spaces. And then it passes that to argc as the command line arguments. So I'm effectively saying argc, argc.c, go2.c, go3.c, go.c, and then my argc program, all it's doing is reading the command line arguments through the argv array. Right? It's not picking up the asterisk. The asterisk being interpreted by the shell, and the shell is calling this with a list of file names. So you have access to this wildcard capability any time that you're writing a program or a script that's reading command line arguments. But if I put my star.c in quotation marks, it's just star.c. If I say vi quote star.c, I'm editing a file called star.c. And now I've got a file in my directory called star.c. Right, so you put things in quotes, it kills the wildcard expansion. But in general, it's being expanded by the shell. All right, so think about that. Ask questions about it tomorrow. And we will continue with this tomorrow.